Hi, so our quantum journey continues. This is just a small stop on the journey today. Another confirmation of the idea that light and energy exist in quanta. Going a little out of order, we're going to talk about Arthur Compton, who in 1923 demonstrated that, yes, energy does behave like a particle. I think probably in our next stop on the journey, we'll go back to 1913 and to Niels Bohr and the hydrogen atom. But in 1923, Compton did demonstrate the quantized and particle character of electromagnetic energy. And he, I believe, won the Nobel Prize for it in 1927, I think. So it was a significant confirmation of the quantization of energy. He wanted to show that a light photon could interact with an electron and deflect it. And the problem is the energy levels of light and an electron would have been too low to really do it in our lifetime. So he used X-rays instead. X-rays have a much higher frequency and a much higher energy. And so his experiment was to show that when this energy encounters an electron, that the electron is deflected, just like in classical physics. You know, when you have a pool ball that hits a pool ball, you know, in a certain way, there's a difference of trajectory. And so he set about to show that an X-ray and an electron could collide in a very particle-like way, in such a way that the electron its trajectory was changed, and also that there was an exchange of energy between the two, neither of which would have been appropriate in classical physics. So let me quickly show you what that might look like. So let's say we've got this X-ray, and it's headed this direction. And, you know, this represents a certain frequency and so forth for it, certain wavelength for it. So we've got this X-ray. And again, Compton is showing that an X-ray can behave like a particle. That's crazy talk, right? X-ray is a wave. It's electromagnetic radiation. It's not a particle. But he wanted to show that an X-ray could actually interact with, say, an electron in like a particle would. So this is the before. Before. Let me draw a better line here. That's the before. Now here's the after. What he found is that actually the electron was scattered, that there was an angle of incident, you know, and reflection, like in classical physics, and not only that, but the electron gained energy from the encounter, and that the wavelength, see you have a shorter wavelength here and a longer wavelength, which indicates that energy has been shared with something else. This was revolutionary, but it indicated that in fact light could, or in this case an X-ray, electromagnetic radiation, could behave like a particle, and that it did have a quantization of energy. And so the Compton effect, or Compton scattering, was again a kind of definitive demonstration of the quanta that Max Planck had proposed way back in 1900, and that Einstein had verified with the photoelectric effect. And so, as I said, Compton received the Nobel Prize, shared it actually in 1927, for his work with scattering and showing the quantization of energy, and that electromagnetic radiation could also behave as a particle. And so yet another small stop on our journey in Schrodinger's course. Is it a course? Is it not a course? We'll find out in my quantum journey.